Alright, hi, my name is Joshua Hardesty, and this is my second bi-weekly report looking at the spectroscopy of ammonium nitrate and sodium nitrate in water. This is also in conjunction with Miles. We'll having two parts to this presentation. So just a reminder of what is Raman spectroscopy. It's when photons are shot at an atom or electron cloud, and it boosts those electrons to a higher energy level. And when those electrons, they relax again back to the ground state, they produce another photon, which is a different frequency and different energy than the one that was initially put in. And this is actually kind of interesting cartoon. That's supposed to be Raman. He actually thought that he could see the shift in the change of light with just his eyes. This is kind of just a timeline. I'm sorry, the background's really not good. The color is kind of being weird. But the idea was introduced in 1923, and Raman won the Nobel Prize for it in 1930 in physics. And there's some important dates. 1961, they first used a laser to get the Raman spectroscopy. That's important because that's actually what we use and what most people use. 1977, surface-enhanced Raman spectroscopy was developed. And that's really interesting. You can actually get more accurate results to times a billion, so 10 orders of magnitude better. You can find specific molecules with surface-enhanced Raman spectroscopy in different substances. And Raman spectroscopy with CCDs, charge-coupled devices, I believe. They actually won the Nobel Prize a few years ago. And that just allows for a better, or you to be able to process lower, smaller signals. Phase 1, the spectroscopy of sodium nitrate at a distance. Our objective was to determine whether decreasing the distance increases the clarity of the signal. Fairly obvious. We tested distances 1 meter, 2 meter, 3 meter, 4 meter, 5 meters. This is just our setup for our lab. The top right here you have the PVC pipe. We fill this up with sodium nitrate and water of certain concentrations, and that's our mirror. And the mirror actually is, I believe it's half a wavelength. It's really flat, and the difference between the elevations are about half a wavelength of light. And this is our setup. This is actually the laser that we shoot, and this is the computer or program we use. It actually has a CCD detector, has to be kept at negative 50 degrees. And this is just our different lengths. In phase 2, we test different concentrations or their effects. This is kind of a general. This is one of our new graphs. Kind of general what we would like to see. But our objective is to determine whether increasing the concentrations of the solutions increases the signal, and we'll be using these concentrations. This is just a picture of of all the concentrations and how we did it. We created the concentrations, then filled the PVC pipe, took spectroscopy, and then repeated it for different distances. In our creation of the solutions, actually, the numbers we used were kind of misleading. We were told to use a certain amount of ammonium nitrate and sodium nitrate. However, we thought that the method they were using was bad because they had compared mass-to-mass ratios, and we thought we should be comparing number of molecules to number of molecules, or moles. And when we calculated what the mass gave us, these were the actual concentrations of the solutions that we were doing when we wanted this concentration. So in future, we brought this up to the people we were doing it with, but they told us just keep doing it this way, or the way we've been doing it with comparing mass-to-mass ratios. But we plan to further try it with using actual concentrations, or not concentrations, number of molecules to number of molecules ratios. And so what happened to ammonium nitrate? I've been talking about sodium nitrate the whole time. We're still getting to that. All we've done is the sodium nitrate so far. It takes a while because each of these measurements takes about 5 minutes, and there's 70 plus measurements to take, so there's a lot of time in between.